Mark Thomas, where are you at? He and Rich invited me to fill in for this slot. And so I told my wife, this was back in August, I told her, I said, you know, Apache really needs me, you know, for this. It's really important. And she's like, who canceled? Man, I can't even get respect from my own wife. All right, so this is the anatomy of a secure Java web app using Apache Fortress. For the next however long it takes us, we're going to think about how we should be securing web apps if we pulled out all stops. So that's me. There's my timeline up there. I've been coding for a long time. I tell people I've made a pretty good living writing bad software. And then half the time they're like, you know, seriously? And they'll say it's all bad software. But so I've been doing Java since '99. About that time, my manager tapped me on the shoulder and pulled me out off the line and said, hey, I want you to go talk to this guy over here about doing security. And that guy was my age now, and he was similarly old and gray-bearded and all that. And he was real sarcastic and mean, kind of like I am now. And I understand why he got that way. And I've been doing security ever since. So I'm going to try to impart on you some lessons I've learned. This is an editorial. So, you know, I've got a bunch of slides here. And so, you know, stop me if I say something wrong. Let's learn together. I'll probably be the one learning here. Oh, by the way, I'm on the Apache Directory project. I've been contributing to that project for about 4 years. Also OpenLDAP. And I work at Simus. Simus is the OpenLDAP people. All right, so our agenda, we're going to have a quick look at the OWASP vulnerability scanning tool as it relates to the Java remote code execution vulnerability. And I'm saying a quick look at that. And then we're going to take a deep dive into some end-to-end security examples with Apache Fortress. And then we're going to talk about role-based access control, attribute-based access control, and how the two can work together. And that's really, that's what I've been doing this talk for about 4 or 5 years, and it always changes a little bit. And that's the new stuff right there. So I've got a bunch of slides. There's a lot of details on there. And so I would recommend that you don't try to capture that with notes and just download them. All the links and everything's going to be behind that right there where it's published. And let's just try to think about this from a big picture perspective. So what's the problem? This is 2018. Why are we talking about security? Haven't we figured this stuff out yet? And so clearly we haven't. And the episode with Equifax last year, I think, really brought the issue to the forefront with the realization that in a lot of cases, we're just playing lip service to security, and we're not really doing what we should be doing. So what happened at Equifax? And I think we all know. We're all Apache. We know what happened there, right? And it was CVE 5638, which is a vulnerability inside of Apache struts. It's not really Apache struts problem. They sort of inherited that because, and we'll look at that in just a second, but 5638 is a remote code execution vulnerability that's sort of part of the Java platform. So what happened? Basically, the attacker was able to trick the server into uploading a string that was then executed as a program. And that program was able to execute a system command and take over the server. And once you've taken over the server, once you can get to the system, you've lost the plot. It's game over. So the solution, back up. The struts vulnerability was patched in April of 17. And Equifax chose not to apply that patch. So, and I think it was in August when we actually figured out what had happened. And so they were negligent, obviously, in not applying that critical security patch. Had they patched that, that vulnerability would not have occurred. Okay. So what's the point? The point is, let's make sure we've got all the appropriate patches applied, and we're safe, right? So how do we do that? How do we ensure that our software is free of known vulnerabilities? One way is to use that tool right there, which is the OWASP dependency checker. So I just put that into my project, which is Apache Fortress. I mean, I think it took like 10 minutes to put it in there. If you're Maven, it's falling off the log easy. I'm pretty sure it has other options. If you're Grails or other sorts of build tools, they've got other sorts of plugins that work. But basically, you just drop some XML in your build file that enables this plugin, a Maven plugin that does that dependency check. And when you run it, when you execute it, and if you're a project, you would run that before you released, right? You would run that plugin against and basically what it's doing is it's looking at all your dependencies, comparing it to the list of vulnerabilities that's in the NIST database, right? And if it finds a match, then it will give you a report. So when I ran it against Apache Fortress, it found all of those. I'm like, holy crap, And specifically, it's this accelerator API, which is a little tiny sliver of code that we use from a group name that's org.openldap. And because the group name in that library is org.openldap, the dependency checker flagged all of these OpenLDAP server-side vulnerabilities, things like buffer overflows dating back to 2002. So it's a false positive. A Java-side client Java library that's talking to OpenLDAP or any other directory is not going to be vulnerable to native problems in the server itself. So those were false positives. But you can suppress them very easily, which I did. And so that's kind of an annoyance. And it's a little bit of an indictment on that tool in that was a fairly sort of a weak, I thought that was sort of a weak matching algorithm on that particular aspect that it flagged it. But nevertheless, that does not negate the value of that sort of a thing. And so I highly encourage you to, and you probably already are, use this tool with your releases. Okay. Great. So how do we ensure that our software is free of vulnerabilities yet to be detected? And so that's getting back to my line, all software is bad. So I would assert to you that the set of unknown vulnerabilities is a heck of a lot larger than the set of known vulnerabilities. And so there's an infinite number of vulnerabilities in our code that have yet to be detected. And so that's really what we're going to talk about, and that's what this talk's all about. Is how can we sort of protect ourselves from those? And it can't practically be done. I mean, there's no tool that you're going to run that's going to be able to detect a vulnerability that, before the zero-day exploit doesn't happen. But there are some things we can do. We can follow best practices. Okay, well, what kind of best practices? Well, one of them is, I'm not even going to read that to you, the principle of least privilege. Okay? What's the principle of least privilege? Well, that's what we do when we run Tomcat and we run it as a non-root user in the process, is we're practicing the principle of least privilege in that we're not exposing that process to every folder and file on that system because it doesn't need to be exposed to that. So we run it as a user that has only exposure to the folders and files that are necessary for it to complete its job. So that's a very simple example of practicing the principle of least privilege. I'm not going to read that either. Okay, so what happened at Equifax? Back to, this sort of principle of least privilege in terms of what happened at Equifax. Again, it was a Java object serialization exploit. So how does that work? And I think we probably all know that. But in Java, the serialization interface, there's a method that you override where you can basically do anything in there. And so that method right there, in terms of Equifax, that's basically that was the leverage they used, which was to be able to, when that object was uploaded and deserialized, it was able to run its program. Okay? So let's just not allow our programs to do things like that. So how can we stop that? Well, one way is we can practice mandatory access controls with facilities like the Java Security Manager. So I hear the groans in the back of the room. Java Security Manager is a much maligned subsystem. It's been around since the very beginning, but nobody uses it. Who uses the Java Security Manager in here right now? One person. And there's reasons for that. Okay, it's not, I don't want to say that it's impractical, that you can't get it to work. It does. I think if you try it hard enough, you can get it to work. What benefits does it bring? Mandatory access control. That program that's running inside of that JVM can only do what you allow it to do. As soon as you enable that job security manager, if that system tries to shell out and, for example, read a file and execute it, you're going to get an access control violation. So you can just prevent it that way. SE Linux has similar capabilities, although I don't even know Red Hat guys that use SE Linux. So I've got a sample right there. I'm not going to do a demo on it. It's pretty straightforward, but it kind of shows how this works. If you're interested, you could try it out. What I will say is one more thing on the Job Security Manager is even if you don't want to use it, say it's performance, you can't live with the performance degradation, which that's a problem people tell me. At least run your application through it, turn it on, and look at what your application's doing. I think you might be surprised at the operations that's going on inside of your application. That will give you insight into understanding the attack vectors that your application has open to it. So even if you don't use it, do this and try it out and learn about that app, okay? So it's not a perfect solution. That's why only one guy raised his hand. Another problem is it doesn't really play well with reflection. So reflection is Java's way to instantiate objects dynamically. So now you've just cut out every parser, XML parser that's ever been written. Things like Spring won't work. So in order to get around that, you have to suppress access checks on reflection, which now you've just opened up another door, because reflection is a known way that vulnerabilities occur inside of an application. Okay, but so we're not dealing with absolutes here. We're dealing with, approaches that move us to a more secure environment. Okay, so one day maybe with the improvements that have gone into Java 9 and beyond with modularization and improved encapsulation, we might be able to have a mandatory access control facility that actually doesn't have, that's so hard to use. That's my hope. We'll see. In the meantime, what do? Back to our security principles. Best practices. Another one is defense in depth. What's that? The building up, layering, and overlapping of security measures is called defense in depth. In contrast to a metal chain, which is only as strong as the weakest link, the defense in depth, aims or fail, other measures will continue to provide protection. So that's where you get this onion right here, where the network surrounds the host, surrounds the application, surrounds the data. And so if one of those barriers fails, another one picks up the slack. So how's that work? Well, so we're all in here for Java, right? I've got my little Java dude here. So what are our layers that we have? So these are the layers that I've identified. And this, in an application we're going to be looking at, these are the layers that we're going to be dealing with. You may have a different set of layers. But on the outer, we have Java SE security, which is, we've already talked about, that's mandatory access control. Secure socket extension, that's confidentiality. EE security, that's authentication, coarse grain authorization. Spring security, we're going to use for medium grain authorization. Web app framework is for controls, databases for content of the data. So all these layers have different things that you can do with them. They're not all the same. So, back to these layers, am I saying you got to do security in all those layers? No, of course not. I'm saying these are the layers that are available to you as you decide as security practitioners what you're going to do. So for example, if you are a healthcare provider and you have sensitive data with patient information in there, perhaps that's subjected to HIPAA regulations, you might want to think about beefing that layer up a little bit down in the bottom and not just leaving it wide open. That's just an example, okay? So it just depends on your requirements which one of these layers that we're going to do. Of course, I said in the beginning, we're pulling out all stops, right? So I'm going to show you an application that has all these things turned on, and then you can tell me how crazy I am. All right, so each of these layers have different purposes. They don't all do the same thing. We already talked about Java SE security. JSSE, we're now in the age where we just encrypt everything, right? So that's not even up for discussion. Just every remote resource should be encrypted, period. End of story. Java EE security, that's another one that's kind of like SE security. People groan, they don't want to do it. They don't understand it, they don't understand the value of it. It's just a pain in the, you know what? Web developers hate it because it interferes with their web flows and how they like, it kind of cramps their style. But it's the deadbolt on that application. And that's basically where you're delegating that basic security to the container. And I don't know about you, but me as a security guy, I'd much rather be able to point to these guys back here in the back of the room and say it's their fault, the Tomcat guys, they broke it, then I want to be able to say I'm the one who did it. Okay, so that's your deadbolt. You just use it, you don't have to worry about it. Spring security, does a lot of things, but here we're going to use it for, once you can get in that building, which rooms can you go into? Which pages can you hit? With that framework, you can get in the room, what equipment can you operate? In the database, you can operate that piece of equipment, what channel can you watch? What content can you view? So they all have different things they can do. Okay, so this example right here is in my GitHub account, Apache Fortress Demo. It's been around for 4 or 5 years, and I keep it up to date. And so that's basically, you can see all those layers again, where basically I'm doing all those things inside of this sample app. And so I'm not going to go into the installation or the how-to on this. We're just going to talk about the broad strokes. If you want to try it out later, then be my guest. So that application right there has 2 areas of access control. One of them is declarative, which are all these things. Declarative means the programmer doesn't have to do anything. The others are programmatic, which are down in the web and database layers, and that's where the programmer has to do something. Now, all of this stuff is dependent on what your framework is. So, for example, in the web app here, I'm using Wicket, Apache Wicket, so you have certain capabilities that you can take advantage of. The data access object, I'm using MyBetas. There's different, depending on the framework and the container, you're going to have different things. So this is not a prescription to say you got to do it this way. If you look at this app and you say, well, why did you do security in that layer that way? Just keep that in mind. All right, so we're going to start out with Tomcat. Of course, we're going to turn on HTTPS for the reason I just said. And then we're going to put the deadbolt on the front door. How do we do that? Well, there's a few specifications for Java EE security, but this is not a Java EE security talk. So we're not going to go into that. Although if you are interested in this space, I encourage you to get to know those. And if you're not using them, at least understand why you're not using them. In the case of this application, we're just going to use a Tomcat realm. With the Tomcat realm, that's a database of usernames and passwords and the roles. So Tomcat comes out of the box with a number of realms. There's the in-memory realm, which is a file, which you would never use in production. Or you at least wouldn't use it in production for end users. And then there's the JDBC realm, which is for storing stuff in a table. And I would kind of say you wouldn't do that in production either, just because of now you're getting into things like hashing of passwords and stuff that really is, for me, as a security guy, I don't want to have to be worried about that. But this application is using what's called the Fortress realm. So I'm a Apache Fortress guy. The Fortress realm maps back to the Fortress policy database, which is a directory, but it has a particular schema that's different than, say, the LDAP realm that Tomcat has. So the realm can be deployed in a couple ways. It doesn't really matter for this talk. It does matter that you're going to, in this case, you're going to be pulling in the realm dependencies into your application. So you'll add the realm dependency to your POM, and it'll pull those into your web app. Because basically, I guess it does matter. The realm implementation, which is Fortress Core, is actually going to live inside the application itself, not inside Tomcat. So Tomcat's not going to be exposed to those libraries, which is very important. You don't want to expose Tomcat to things like that. And then the Fortress context realm has a deployment descriptor called the context.xml that basically sets that up. You can set up the list of default roles You say, well, why would you do that? Well, if you've got a full-size security system, you might have 1,000 roles. Maybe your application only has 10 or 5. So you can shrink down that set of roles to be considered with that. And then it's also multi-tenant, so you can specify the tenant name there. For this to work, you got to drop what's called the proxy jar on the Tomcat lib, and it's about 15K in size, and that's just enough to kind of bootstrap this. But that's the only thing that's exposed directly to Tomcat, is that little tiny jar right there. Regardless of which realm you're using or which Java EE security specification you're using, there's going to be a deployment descriptor that specifies the contract between the application and the container. What I want you to take away here is, in this case, we're using the Java EE security as a deadbolt. So we're going to specify one and only one role name inside of that file. So we're not going to have to, like, our policy changes and we got to redeploy or whatever. Just one role, and that's your deadbolt. Can you hit the app or not? Yes or no? Coarse grain authorization. And of course, it will route you to the login page for authentication. Okay, so I'm talking about a security system as if it exists, but we haven't even talked about what it is. So, and what we're talking about is a policy decision point that your application and the container, they're all going to point to, that's going to keep the users and the roles and all that stuff. So I'm prescribing this fortress thing, and it's a RBAC policy decision point. What's that? Role-based access control. What's that? You know, cue in the bombastic music right here, okay, role-based access control. And, you know, we're going to boldly go where no access manager's gone before kind of thing. But has anybody heard of this specification? Insights 359? See, we talk about role-based access control as if it were a generic thing. Like, oh, we got some roles and we got, maybe they're groups or something, and then that's role-based access control. But in reality, role-based access control is a specification, okay? And it's governed by, in this case, it's, and we'll get to it in a bit, but it's governed by ANSI. And so there's really sort of a very specific and powerful way that a role-based access control system is supposed to work. And so we've got RBAC 0, that's sort of the base. In order for a system to be deemed compliant, then it has to at least be able to do RBAC 0. What's RBAC 0? It's users, roles, permissions, and sessions. What's a session? A session is the context for which a role is activated. Just because that role was assigned does not mean that it's going to be activated in the session. And that's in keeping with the principle of least privilege. Only give the user the power they need to do their job at a given point in time. And so we have some higher order things too, because it sets up some higher order functions. For example, hierarchical roles is inheritance relationships between roles, which is a way of simplifying the role engineering process. You've got static separation of duties, which is mutual exclusion constraints between assigned roles. Perhaps you have a couple roles that have a toxic combination. Check writer, check approver. You don't ever want somebody to have both those roles at the same time for whatever reason. So you can prevent that in the policy decision point at administration time using RBAC 2. And RBAC 3 is dynamic separation of duties, and that's mutual exclusion constraints between activated roles. So how's that different than 2? Well, 2 is assigned. So I can be assigned, so maybe I can be assigned check writer and check approver at the same time. That's fine. We don't have a constraint there. But we have a dynamic constraint that says I can never activate both of those in my session at the same time. Okay? So we're going to look at that concept here in a bit. So these slides are all just to say that, you know, role-based access control is not just groups and users and things. It's something that's been kicked around in the academic and the government world for decades. And in 1992, we had a couple guys out of NIST, David Ferrai-Olo and Richard Kuhn, who drafted a very influential paper that kicked off the model that's now sort of the precursor to the specification. Eventually, that model was formalized into functional specifications by this guy, Ravi Sandhu, also from NIST. And then later, it was turned into a specification, first in 2004, and then in 2012, it's been updated. And there's a companion spec called Insights 494, which applies attributes, dynamic attributes to the decision, i.e. ABAC. And so we're going to get to that in just a second. Okay, so this object model is defined. The shapes of the data is defined. So you have the things that you would expect in a security system: users, roles, permissions. A permission is a mapping between an object and an operation. Customer account read, right? That's a permission. And then we already said what sessions was. And then there's a functional model. And the functional model are the shape of the APIs. And so there's three interfaces. The one we're going to talk about today is the system. So that's for access control. So that's these right here. These are the things that happen at runtime. We create sessions, we check permissions, we add and remove roles from the session as needed to fulfill the user's needs as they meet the security policy. Okay, so if you're interested in this aspect of it, which I call role engineering, which is how do I take my application and get it RBAC compliant, and how do I get a policy, and how do I instrument the code, and all that, then I encourage you to look at this sample right here, this role engineering sample, which is for that, just to kind of teach you that it's not really about end-to-end security. It's just about kind of teaching you how to use RBAC. But we're not going to be doing that today. So where was I before I got sidetracked on the Starship Enterprise? Oh, okay, so we're installing a policy decision point. All right, so how do we do that? Back to the Fortress project. Apache Fortress is the role-based access control implementation, and it uses what's called a directory server as the database to hold the data. Does everybody know what a directory server is, LDAP? Good. Okay, so Apache Fortress works out of the box with two directory servers. One is Apache DS, which is the directory server of my project, and the other one is OpenLDAP, which is the directory server for my other project, which is the OpenLDAP Foundation. And so the quick starts to install that and get it set up are behind these links. Okay, so back to our application end-to-end security. What else do we got to do? We just opened up a remote resource, so we ought to encrypt, right? We're not going to send credentials over the wire unencrypted. So we're going to do that. We're going to enable Spring Security, like we said, which is locks on the door. So we're going to have a policy in the application to say, to hit page 1, you got to have this role. To hit page 2, you got to have that role. To hit page 3, you got to have another role. So Spring's going to do that for us. So we're now kind of pretty far into our list of things, and we haven't even woken the programmers up yet. So they're off doing what programmers do when we don't need them. God knows what that is. Drink beer. Actually, that sounds pretty good. You got one? So we're going to get into the, so that we're going to wake them up, and we're going to have them do some stuff. So what are they going to do? They're going to add security in that layer, the web app framework. So I already mentioned this is Apache Wicket web app. So the way that I did it in this application is I basically overrode Wicket controls. So there's a secure button, there's a secure link, there's a secure this, a secure that. And so that's how they would instrument the code there. So in order to hit this button, you got to have that permission. To hit this button, you got to have another permission. And then finally, we're down in the database, and we're going to apply controls there. So in this case, it's my beta, so I've got a data access object where I've instrumented with calls to the permission check. Now we're back to, well, why would I need to have security here in the web app framework and there in the database at the same time? Wouldn't one or the other suffice, right? It's the same call. Well, what if the attacker was able to circumvent your web app? What if they're able to instantiate your data access component via reflection and bypass that control? Then what? Okay, so finally, we've opened up another resource. We've got a database. So we need to encrypt that too. Okay, so that's the end-to-end security of this application. You can try it out. It's got infrastructure you got to install. There's a database, there's a directory, there's a sample policy. There's also a test module that you can do to test it. Okay, so those are kind of what I'd call the non-functional requirements. So let's talk about the functional requirements of this sample app. So it's very simple. There's 3 pages. The pages have buttons on them, and then there's like a list box. You can pull back data from and you can add, update, delete data, just like a normal sort of a simple business app. As far as the security policy is, we have 3 pages. We have 3 sets of customer data. So there's customer 1, 2, 3, customer 4, 5, 6, and customer 7, 8, 9. So I'm showing you fine-grained access control. So 3 pages, 3 roles. I've got 1 role for every page to customer combination. So 3 pages, 3 customers, there can be 9 roles. So in order to give a user access to a page for a particular customer, they've got to be assigned that role. So furthermore, those roles have a dynamic separation of duty constraint placed upon them so that they can activate one and only one, or I should say at most one of those roles in their session at a time. Okay, so we're going to look at that right now. So we're able to do things like this, where we can kind of slice and dice however we want. We can say, hey, this user here, 123, has access to all the pages in the app, but only for one customer, customer 123. And we got user 1, he has access to a single page for all customers. Or this user here, user 1, 123, has access to a single page, single customer. Okay, so that's kind of the security requirements behind it. So let's see if it actually, what it looks like. I'm going to fire this. So which one do we want to do first? Let's do user 123. He has all pages for a single customer. And I am the GUI designer of this, and I know you guys are really liking that GUI. So it's a beautiful GUI. Okay, so I just logged in. That was the container I logged in with, Tomcat, the Tomcat realm. And so then it dropped me into the landing page. You can see that I have the links to the different pages there. So the web app framework is aware of the policy. It's aware that I have access to those 3 pages, and it's presented me to the links to those 3 pages. So I can click on a link. I get to a page, and you can see there's some entry fields there. Can you all see that? Okay. And, but there's no buttons. Where are the buttons? Well, this user hasn't activated a role yet, right? So we're going to activate a role. So we're on page 1, so let's do page 1, 1, 2, 3. So I activate that role. Now the buttons pop up. And so now I can operate on that data. Like I can pull back data. So what happens if I change the customer to 456? I can't do it, right? Because I don't have that role activated. And so, and indeed, this user doesn't even have that role to activate. But let's just say that they tried to. So let's just say, because I'm the web app developer and I built a crappy system, that they can just enter in. They don't have to select it from a drop-down. They can just enter it in. So I can just say page 1, what was it, 456. So I'm going to activate that. Of course, I can't because the policy decision point knows that I haven't been assigned that role. So the same thing happens with page 2. I go to page 2. There's no buttons there, so let's activate the role for that because they do have the role for that. So page 2, 1, 2, 3, I'm going to activate that. And I get another error, and what is it? I can't activate 2 roles in my session at the same time. I've got a dynamic separation of duty constraint there. Does that make sense? Okay, so before I can activate that second role, I've got to deactivate the first role. So I would have to deactivate page 1, 1, 2, 3, and then activate page 2, 1, 2, 3. And then I go to page 2, and I got my buttons. Okay, so that's just kind of how that works. So let's just see another one real quick. I want to illustrate another concept. So let's do user 1, 1, 2, 3. They have access to page 1, customer 1, 2, 3. So we'll log in as that one. And while I'm doing this, I want you guys to think about what's wrong with all this, because there's something bad wrong with what's going on here. Question?
Yeah, but I don't want to interrupt.
Okay, well. Yep. Okay, so user 1, 1, 2, 3, same thing. They've only got access to one page, so they hit the link for page 1. I'm not going to go through all that, run around again. What I want to show you here is, okay, so they can't get to page 2, but their users, they're savvy, right? So he's just going to change the link to page 2 and bypass the web app framework. And Spring knows that they can't have it. So that's defense in depth right there. One layer fails, the other one picks up. They all do different things, okay? So that's basically what I wanted to show you with this application. So I already mentioned there's a Selenium test case here. A very important thing with security is testing. I was once associated with an application team that let a regression go out to where on the sign-in screen you could enter a valid user ID and no password and it'll let you in. Now if you entered a password it would validate it, but if you entered no password at all it would let you in as that user. That bug was in place for years. So I mean testing, that's where automation comes in. Okay, so that demo is in my GitHub account. All right, I already mentioned we still have a problem. What is it? There's something bad wrong I just showed you. Okay. Our roles are exploding, right? This is one of the caveats of RBAC. Exploding roles. What do I mean? The number of roles you need is the Cartesian product of the number of roles you need times the number of relationships. So in our case here, we had 3 roles, we had 3 relationships, so we need 9 roles in order to do fine-grained authorization. Well, that's fine if you got 3 relationships. What if you have 50,000 customers? You know, are you going to have 150,000 roles? Are you going to run into something like this? You got a power user and you've got to assign them 15 roles to get into an application. Okay, so this is why people don't use RBAC right here. This reason right here, this is it. Now, I've seen it many times, is the exploding role problem. So the solution is we're getting back to Insights 494. We're going to use attributes to constrain under what condition roles may be activated. How do we do that? Well, so back to our same sort of use case. We got 3 pages, we got all these customers. We can shrink it back down to three roles. And then on the user object itself, we can put constraints. So we can say the user 1, 1, 2, 3 has access, for page 1, it can only be activated on customer 1, 2, 3. So we can do this in very complicated ways. We can say, you know, maybe this user here has access to all roles, but only for a single customer, just like what I did before. And, you know, this user has access to only a single role for, or I should say, this user has access to all pages for a single customer. This user has access to a single page for all customers. And you can slice and dice it in just the way that I just did, doing a very brute force method. So back to the power user, he's not assigned 9 roles, he's back to being assigned 3 roles. Okay, so how's that work? So basically this is RBAC, what I showed you in the first example, where you know, this user 1, 2, 3 had access to all pages for a single customer, so he had to be assigned to 3 roles, that the role was basically page to customer role in the name. So now, user 1, 1, 2, 3, using this constraint, he's still assigned to 3 roles, but each of those roles, they're generic roles now. They're not specific. And so on the user object itself, rather than having it as a role assignment, we have a constraint. Now this probably looks about the same to you, but this is a very powerful difference. So how does this work? We have a policy construct where we can basically constrain a role. Well, the first thing we'd do is we'd say a role special. So page 1 is special. We're going to say he's going to be constrained by customer. Of course, that could be any attribute. That could be account, that could be organization, it could be location. It doesn't matter. But we're saying to the security system, don't ever activate that role unless it matches that constraint that we're going to do. And then as far as on the user, we can say for a user, they have that role, but they're constrained to a particular customer. Does that make sense? Is this making sense? Okay. So a code sample, in order for this to work at runtime, back to create session, is that, I hope you all can read that, but the runtime is going to push in, they're going to assert the constraint and the value at runtime. And so that's basically, in this case, the runtime is going to be on behalf of customer 1, 2, 3. And so any role that gets activated for those pages has to have that matching constraint on that user object. Okay, so I put together another sample to demonstrate this. It's called the Apache Fortress ABAC demo. It's identical in the use case, the functional use case as the other one, but I stripped out all the infra. There's no database, there's no SSL, there's none of that. It's just showing the buttons, and it's the same policy to show you how the policy would work. That's also in my GitHub account. So let's look at that real quick. and then we'll call it a day. All right, so in order to make this work, the first thing I got to do is I've got to change the policy, because I had those users that had one set of policies with the old way of doing it, so now I'm going to do it with the new way. So I'm going to find the right window here, and I'm going to run a policy script to change that policy for this new way. Okay, so that's done. Now I'm going to pull up this new app. Okay, so you remember user 123? Let's go in as him again. Okay, looks the same, right? Same ugly color, same ugly GUI design. Same thing with Spring presenting the links. They can click on the links, they can get in there. There's the entry fields, there's no buttons. But now we don't have a drop down, we have an entry field where you enter in the customer number that's to be considered. So in this case, we're saying 123. So I hit that and I hit activate. That's basically going to push that attribute into the session. And so now the runtime is going to look at that and it's going to activate any roles for that user that has that constraint, customer 123. There the buttons are, I can now operate on it. So it's the exactly same use case in terms of security that's being satisfied, the same fine-grained authorization, but now we're doing it with coarse-grained roles and fine-grained in terms of the ABAC constraints. Okay, so that's what I wanted to show you of what went wrong before and what's been fixed. So that's part of Fortress 2.02, which was just released. And so there's going to be some more on that if you're interested in it. I've got another sample, this RBAC ABAC demo, which is actually, if you want to try this out at home, try that one. This is probably the more succinct example with the more straightforward use case. And that's it. Closing thoughts, never allow users more than they need to do their jobs. That's the principle of least privilege. Apply security controls across many layers. That's defense in depth. RBAC may be combined with ABAC for fine-grained authorization. And there's my examples if you want to check them out. And again, these slides are published, guys, but yeah. Oh, there's a bonus here too if you're doing SAML. Fortress SAML demo shows you how to combine a SAML 2.0 endpoint with role-based access control. That's what I used to talk about here, but SAML's old school stuff. So that's it. I hope you guys got something out of this. I don't know if we got any time for questions. Go ahead.
So, two questions. First of all, so only one role can be activated at any given time, or was that a constraint specific?
That was a constraint specific. So you can set up a dynamic separation duty constraint that is basically any set of roles. You can have any number of roles in there, obviously more than one. And then you also set up a cardinality, which says, because you might have 4 roles and say, well, you can only have 3 of them. So the cardinality would be how many out of that set can be activated. And the same is true with static separation of duties. Works exactly the same way.
And the second one, you showed on the page that the buttons only show up when the role is activated.
Mm-hmm.
So can you show a sample code of where you check that? Where does the
Yeah.
application check that?
So, I mean, it's, again, we're in, let's talk afterward, I'll show you exactly, but just sort of from broad strokes. That was in the web app framework, so remember I said that was programmer aware. So in this case, it was Apache Wicket. So, Wicket has an AJAX button control. So I overrode that control with what's called a secure AJAX button. And then in the constructor, you pass it the permission name. And then that button, that control, when you will then, it does 2 things. One is it won't appear if you don't have that permission in your session, which is what you saw. And then the second thing is when you push that button, you can also call it again even. So, but anyway, so it just depends on what your framework is, how you would do it, but that's how I did that one. So, and if you go to that example, you can look, there's 3 classes for the pages, page 1, 2, and 3, and it has those buttons in there. You can see how that was done.
I'll check it out. Can you please just put the slide with the
Oh, yeah, sure. Any other questions?
You were thinking about SAML again, you kind of trailed off. What were you saying about SAML?
Oh, there's a sample on SAML. The question is, what was I saying about SAML? There's a sample right here that just in the same kind of way that I've got these other samples where you can basically build and deploy it. And this one does SAML with an identity provider that's a common one. Have you heard of SSOcircle.com? Yeah, so you don't have to set up an IDP. And then it uses Spring SAML inside the app. And then basically what it's doing is it's showing you how you can combine a SAML 2.0 endpoint with a role-based access control policy inside of an Apache Wicked app, which is, the only web app framework I know how to code in. Okay, so back to the beginning where the slides are. Any other questions? No? You guys have been a great audience. Thanks for not throwing me out of the room. Thanks. Enjoy the rest of the show.